Okay, so now let's look at this general quadratic. There is an x squared term, there has to be. Now we have got a term involving x and a constant, so the general one. There's two methods we're going to look at. This is the one that we're going to focus on mostly, because this is generally always works. It always works whether or not you've got a b or a c. So it'll work in the two scenarios we've looked at already, as well as this. But don't forget the shortcut for the solution to if there's no constant or no x term. This factorising method we will look at. It's not general. In other words, sometimes it's very difficult to get a solution using this method. However, as we'll see later on, we use the idea of factorising anyway, so we need to know how it works. This perfect square method, though, gives us a formula. And we're going to use that formula to solve this equation that we had at the beginning. This is our simultaneous equation. This is the scenario we were stuck with at the end. How do I solve this? 3x squared minus 4y equals 2. And we're going to use this general method to do it now. And the method, and I'm quite confident that most of you will have seen this, is to use this formula. That if I want to find out what x is in a general quadratic, I use that formula. X equals minus b, make sure your b doesn't look like a 6, plus or minus the square root of b squared minus 4ac all over 2a. And when you've used it as often as I have, you remember it. That's a formula to find x for the general quadratic. ax squared plus bx plus c. So we use that to solve quadratics of that form. So what are a, b and c in this formula? The values of x squared, the coefficient in front of x squared is a in the formula. That's this a here and here. What's b? The number in front of the x term. What's c? The constant. The only other thing is, for it to work, the right-hand side must be 0. So if it isn't, we've got to make it 0. And then we can use this quadratic formula. So with that in mind, let's have a go at this particular equation. The first thing then is to get rid of this 2 by subtracting 2 from both sides. We've got 3x squared. Oh, sorry. Pause it. Yeah, so sorry, it wasn't that top one. We rearranged that top one in terms of x, didn't we, to get this. So now we've got to get the 6 over the left-hand side, so the right-hand side is 0. So subtracting 6, we get 3x squared plus 3.2x minus 6 equals 0. All we have to do now is plug those numbers into the formula. So I'll write down what a is, what b is, and what c is. And certainly initially, when I start off using these, this is what I would do. What's a? 3. What's b? 3.2. What's c? Negative 6. So I write down my values, a, b, and c. Note the negative 6. And then, what's the formula? Minus b plus or minus the square root of b squared minus 4ac all over 2a. Plus or minus, because whenever I have a square root, the answer could be positive or negative, so that's always going to be there. Now I put my values in. Minus whatever b is. Plus or minus the square root of b squared, 3.2 squared, minus 4 times a, which is minus 6, times c, sorry, b, which is, oh yeah, sorry, what's a? 3 times minus 6, all over 2a, 2 times 3. The only thing to be aware with using this is just be careful. Don't rush and do too much in one hit, because you trip up on the signs. Minus 3.2 plus or minus the square root of 3.2 squared minus 4 times 3 times minus 6 is going to give me plus 6 4s are 24 times 3, 72. Or I could put plus and then the numbers, 4 times 3 times 6 in my calculator. But I try and do as much as I can in my head, if it's possible. 2 times 3 is 6. Then I'd reach for calculator, and I'd I'd use the fraction button, and I'd put that on top, negative 3.2 plus. I can't put plus or minus, so I put the plus in first, square root of this lot, over 6. See what that is, and then I'd go back and change the plus for a minus in front of the square root sign to get the other solution. So try doing that in one hit on the calculator and get the two values for x. So x equals 0.978 or negative 2.04, presumably to three significant figures. Run out of time now, so what I want you to do, and I'll leave this for you for next week, we'll start off at this point, is to now substitute those values of x back into the original formula. Remember, this was simultaneous equations to get y. And then if you check on the notes for the graph that was plotted, you should see you've got the same answers. Okay, where that line cut the quadratic curve. And next time we'll look at further problems in this and also the factorization. But you could have a look in the meantime, look ahead and use a textbook and see if you can suss it for yourselves. Okay, thank you.